Hi guys, and welcome back. Today we're going to continue the questions we were doing previously. As you know, we're doing the Math League contest questions, and today is going to be our fifth video, and we're going to go and do question 21 to 25. Okay. So the first question is easy to read. Please start reading it. N is the sum of infinitely many positive numbers. Is it possible that n is smaller than 1,000? Okay. So basically what it means, okay, we're going to add a lot of numbers, right? Plus another number, plus another number, plus another number. And the sum of these, is it possible that is less than 1,000? Can we add infinite numbers and the sum is smaller than 1,000? Well, let's see. Okay, let's start. I want to change the question for now. Instead of 1,000, what if I put here 1? And will that change your answer? Is it possible to add a lot of numbers? Well, to understand it better, we need to know infinity a little bit better. So if I multiply one infinity by another infinity, what do you think the answer will be? Extremely large number multiplied by extremely large number. Like you could put this in your calculator, 9999 multiplied by 99999. Well, it would be even a larger number. See, this is again infinity. But I have a question for you. This infinity and this infinity, are they the same? All right. Are all infinities the same? Yeah, that's the question. So what if I write this? What if I write infinity divided by infinity? What could the answer be? Well, the answer is, if you say 1, that's one of the answers. When you divide to infinities, it could be anything. Okay, any number, including infinity. The only number it can't be is absolute 0. Okay, but why? Well, stay tight. Okay. Imagine we have x divided by 5. And x is going to positive infinity. What happens? You have an infinity divided by 5. Well, it would still be positive infinity. Now, what if I write x over x and then x? Positive infinity. What's kind of the answer? What is the answer? In this case, both of the infinities are going to be the same, so it's going to be 1. Now, what if I change the question a little and write 2x divided by x? So what is the result? In this case, well, the x's are simplified. It will be 2. Okay. So, but you see, even 2x is still another infinity. X is infinity. But when we're dividing them, the answer is 2. Okay. Now, hold on. What if I write something like this? X over x squared, and x is going to infinity. In this case, what happens? Okay, so we have infinity divided by infinity squared. See, what happens is this number, for example, let's see, x is 10 to the power of 20. But x squared is going to be 10 to the power of 40. When we simplify it, what do we get? 1 over 10 to the power of 20. Put this in your calculator. What do you get? A 0. Almost a 0. Okay. So that's it. You see, this one is going to be almost, let's just clear this part. The answer to this is going to be 0, but this 0 is not absolute. Okay, this is not an absolute. It's just slightly bigger than absolute 0 that we know. Now let's go back to the question. What if I write the numbers like this? We have 1 x to the power of 2, for example, plus 1 to the power x over 2. Okay, and this will continue. Okay, how many of them do we have? We have infinite numbers, but infinite numbers of 1x to the power of 2. Okay, so now x is going positive infinity, and we have infinite numbers of this. What is the infinite number? X. So we have x number of these. Okay, so if I simplify this, what do I get? It's going to be x over x squared. And if I simplify these two, it's going to be 1 over x. And x is going infinitely big. So this will be 0. So what does it mean? It means I could add infinite, right? X numbers, infinite numbers, but each of these is twice smaller, right? It's 1 over that infinite squared. And if I have infinite of number of these, okay, still it would be 0. So not only this question isn't possible to add infinite numbers and add all of them, it could be 0 when you use the sum of this. So let's go back to the question. 1,000 is a large number. Even if the number is 1, we say yes. If it's n is smaller than 1 over 1,000, still yes. Why? We have infinite numbers, of course, but we make each of those numbers even smaller. See, if we have x and x is positive infinity, we'll make each one infinity squares. So they will be really, really smaller, and we add them. It's still 0. So I hope it's clear. So unfortunately, I don't get to see if it's clear. So the answer to this, I would say, is yes. Please tell me if the explanation was any good or not good, or if you understood something from it. Okay, let's move on to question 22. Please read the question. Okay, you could pause the video and do it. Okay, this question is much simpler than it looks. Okay, and for swapping, you could swap, for example, these two rows, or you could swap, okay, these two. You could also flip, okay, but flipping one end to the other end to end. Okay, this is another possible move. So at first, let's just swap this one with this one, and then this one with this one. Okay. So when we do this, these two become yellow, and instead these two become black. Okay. And then this black goes here, and this black goes here. So let's do it. So this will be yellow. This would also be yellow. Okay. And this one will be black. This one will be black. Okay, the first swap, that's just one move so far. Okay, column 1 and column 3. Now, column 4 and 6, these two. Okay. Okay, when we swap them, they will look like this. This will be also black. Okay, this will be black, and these two will also be black. Okay, now the shape is pretty good. You see, these two are here, and they are the same. But I want these two to go down here. Okay, to do that, row 1 and row 5 are swapped. This one swapping with this one. Okay, that's going to be move 3. Okay, with move 3, these will go down. Okay, these two will go up. And they are cleansed. I clean this. I clean this. Well, as you see, the shape is almost made. Okay. So let's see, how is that different? Okay, the only problem is these two, you can see it here. If this number 2 goes in place of number 4, then it will be over. Like all we have to do is swap these two and the shape will become the same. Okay, let's do it so that you can see it. Okay, this one will be cleansed, this one clean, and they will both go down to row number 4. And this one will be clean. This one will be clean. And it will go up. This will go up, and this will go up. So how many moves? Well, with 4 moves. Okay. We just made it with 4 moves. So the question looked harder than it actually was. Question 23. Okay, please read the question on your own. Okay. Basically, we want to make triangles, right? As given below. No, you didn't read the question. The question is here. So, please read the question. So basically, how many colors do we have? We have 6 colors, okay? And with each 3 of the colors, we could potentially make a triangle. So for example, maybe these 3. Or maybe yellow, blue, and then red with this 3. So how many 3s can we pick from this 6 colors? We have 6, and then we're going to collect 3 from it. It's going to be 6 factorials divided by 3 factorials and divided by 3 factorials. So it's going to be 6, 5, 4. 6 times 5 times 4. Okay. Oops. Divided by 6. So it's going to be 20. There are 20 ways that we could pick 3 colors from these. Okay, from these 20, are all of them possible? See, so for example, if I select 5, 6, and 7, is it possible to make a triangle with these? Is it possible for all of them? Well, not for all. See, what if we have 8, 3, and 4? You see, 8 would be this one. It would be really large. And 3 would go here. See, 3 is like this. If I put even 3 here And then pink, if I put 4 here, you could see even if I put them like this, still it's not possible to make a triangle. So this one, 8, 3, and 4 is not possible to make a triangle with these numbers. So how about 8, 3, and 5? Is it possible? Again, the same problem. We can't make a triangle with this. Okay, is there any more? Yes, with 7, 3, and 4, we can't make a triangle either. So we had 20 options, but with these 3, it's impossible. So we need to subtract it from here. So we have 20 moves minus these 3. So we'll have, okay, 17. So how many different triangles can you create? 17 different triangles. Okay, so question 24. Okay, I give you time, please. Okay, please read the question. I'm gonna make it smaller so that you could see all of it. Okay, please read the question. Okay. So my friends live in 10 buildings along the same long straight street as shown, not drawn to scale. This is very important. Well, I would like to build a house in the street at the spot that minimizes the sum of all the distances. So, well, if, for example, we build the house here, you see, we would be close to these 3, almost these, but we'll be very, very far from these houses, okay? So if we just want to look at it this way, I think the middle point of the house would be between 5 and 6, because you see, we are minimizing all the distances this way. But there is a problem, okay, that here says the picture is not drawn to scale, okay? So that means, say maybe these look, for example, I don't know, 2 units, but they're actually like 1 unit, right? It could be shorter, it could be more and longer. So, with this in mind, let's see. Okay, because it's not drawn to scale, what happens in this case, right? Remember, we had 10 friends. What if 10 friends make their houses really here? 1, 2, 3, 4, 5, 6, 7, 8, 9. And then one will go here, 10. See, one of them is really far from the rest of the houses. Well, in this case, where do you think the middle point will be? So probably if you want to minimize all the distances, you would have to go and build your house maybe somewhere around here. You have a one big distance, but you're very, very close to all your friends. Okay, so with this case that I'm presenting here, well, I think what makes most sense is the last option. Okay. See, with that extreme case, because it says it's not drawn to scale, and if they could be extreme like the example I provided, well, it could be any answer. Any answer could be true. So I would select this option. Okay, let's focus on the last question, question 25. Please read it, pause the video and read it. Okay, so here, the three squares have dissected, okay, the triangle into 22 different parts, right? What are the parts? Let me show you. This is 1, 2, 3, 4, 5, 6, 7, 8, 9. They're 22. And we want to see if it's possible to make it more. Okay. But here, in this example, all the triangle, this is the triangle, all the squares are in contact with each side. See, the question says all the vertices means points, all the vertices are in contact, right? But this doesn't not have to be true. See, your squares could also be like this. That's okay. The only thing we need to know is that the squares, okay, all have to be the same size, okay, because it says 3 identical squares. One of them cannot be large, the other one is small. See, for example, in this example that I have here, how many regions do we have? 1, 2, 3, 4, 5, 6, 7, and all of this 8. So not much. So how can we maximize that? I think let's just start by drawing 3 squares. Okay, that's gonna be 1. Where is it? That's gonna be 1 square. Okay. The other one will be almost like this. I hope I could. No. Let's make this a little smaller here. And this one. And this one. And this one. And then we're going to have another one going like this. Okay, let's go a little left. Okay, but are they perfect squares? No. Okay, how about this? Okay, I think the shape is almost good. See, if we have 3 squares like this, how many regions do we have? See, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 already. Okay. Oh, I hope I didn't miscount it, but you could do it and just count it for yourself too. But all of them, we also have another triangle. It's going to be equilateral triangle, but we could put it in a triangle, but this triangle will add more to it, right? So see, for example, if I make a triangle like this, so I hope it will be, maybe we need to make it a little larger, and this one a little larger too, but it's still in contact with at least with some of them. Okay, so let's see if you do it like this, how many you can get. But if you have a ruler, you would do a better job than I did. Okay, do it like this and write it in the comment section how many parts or how many sections did you find? What is your maximum? Okay, that's enough. We have done question 21 to 25. There's still some more videos coming. Take care and bye-bye.